Welcome back, statistics students. We are still inside chapter 5, and we are on to example number 6. And it says you're given the following data, and if you don't have your calculator out like I do over here, you definitely should get it out. It says you're given this data. Okay, can we assume a normal model? Of course, this is a loaded question. You can't just answer that normally. I do help you out here by say verify and give you a couple different plots to check. You should know from now on, though, if I say, can we assume a normal model, there you have to do some checks. You have to look at a histogram, a normal probability plot. You need to run some numbers. Okay, you got to do something. Dot plots are sometimes used, but you got to do something. Okay, our favorites are histograms and normal probability plots. We'll start with the histogram. Okay, so a histogram. First, I need to have the data. So a stat over here on my calculator. Hopefully you're watching. Edit. You can see that I actually already have the data in here. You need to pause this video, take your time, and put the data inside there. Okay, so now that you pause the video and you got all that data inserted in, now what we want to do is we want to make sure that our plots are set up. So we hit second, y equals, which bring up the stat plot menu. Want to make sure the first stat plot's on like mine is, and it's actually highlighting already on my histogram over here. I do want it to pull from where I put the data. I did put it in L1. If you would have put it in L2, you can always hit second 2, which would put L2 in there. But of course, mine's L1. After we have this, we always hit zoom and then 9 for stat. This zooms us into our statistics. Now, this doubles back to a few chapters ago, and it should be on my initial videos, where we say that we cannot have a histogram with just 1, 2, 3, 4 bars. That's illegal. We have to have between 5 and 12. So how we fix that is here on the calculator, if we hit window, you can see that the scale down here for the x goes by 3. Let's just change that to 1s. Okay. Now don't hit zoom 9 because that's going to put us right back to the same thing. Instead we hit graph. Now you can see that it's split those 4 bars up. Okay. If we want to know how tall they are, which really is not super important here, okay, but we can figure it out. If we hit trace, you can see that it starts at 17 here, and that's too big, right? And all the other ones are what? 1 and 2, okay? Of course, there's not a whole lot of data here, and the biggest it goes is 30. Again, we don't have to like write these out perfect or anything like that. For our histogram over here now, when we draw it, what we're going to do is we're going to draw it in here, and we're just going to make sure that we start this here. We could even say that this is 17, okay, and this is 30, but again, it's not super important. We just sketch what we're seeing, okay. This is up at 2, then it looks like it's immediately a 1, right? We have a couple spaces in here, and then it looks like a 1. Couple 2s back to back, followed by a 1, and then it spaces out, and it looks like I didn't give this enough space, okay, which is not a huge deal. Again, we don't even have to have these numbers here. We can just space it out and we can show it this. Now, if it's a normal model, the histogram should be symmetric and unimodal, right? It's tough with to be unimodal when you only have this 10 here. But it doesn't look unimodal. So not unimodal. That's a problem. Okay. This is a serious problem. And the biggest problem here is it's not symmetric. That is a huge flag. Okay. It's not symmetric. Now, most likely, if you had this, okay, and you were answering the question, really you could stop, because the histogram does not support a normal model, right? So you could say, no, we can't, and then a rationale is not unimodal, not symmetric, okay? But because this is an example, I think I'll go on so that you can see when I use the normal probability plot, also known as the MPP. Okay, so we come over here to the calculator again, second, y equals, hit our stat plot, and now we're just going to turn on the normal probability plot. It's the last one in the TI-84. Highlight it, make sure that this says L1. We usually draw it on the X. Zoom 9. Then we can see the probability plot, again, we're not trying to make this crazy accurate. Draw a line, right? We don't have to count these out perfectly. Okay? It looks something like that. And when I look at it, or I should say as I look at it, I think it almost looks like an S curve. Okay? It's not it's not strictly linear. So this is a problem, not linear. When it's not linear, again, I'm not happy with this. I'm not very happy again. Okay? So because of the fact that the normal probability plot's not linear, this histogram is not symmetric, nor is it unimodal, we cannot assume normality. Okay? And normally I would say for whatever, but this is a generic example. It's just some random data, so we don't know what it actually represents. Okay? And that is example number 6. If you want the first 5 examples, please go back, look at those videos. Otherwise, we'll be moving on to example number 7 in the next video.